Hi, my name is Michael, and I'm excited to share our work on WONDERBREAD, the first benchmark and dataset for evaluating multimodal models on business process management tasks. But first, what is the motivating problem we're trying to solve? Put simply, companies waste a ton of time on inefficient workflows and tedious digital tasks today. 92% of jobs require digital skills, and yet the average knowledge worker wastes roughly 3 hours per day on digital tasks that are unrelated to their core responsibilities. So how do we improve these inefficient workflows? Well, like any good scientist, we need to be systematic about it. And the systematic measurement and improvement of workflows is referred to as business process management, or BPM. BPM projects typically progress in 4 stages. First, we document the workflow that we want to study. Second, we make sure that everyone is on the same page through knowledge transfer across the organization. Third, we analyze the workflow and suggest ways to improve it. And fourth, we can try to automate the most repetitive subtasks within the workflow. Contrary to where most of the AI automation hype is today, however, automation is actually a relatively small part of most BPM projects. Roughly 60% of the time is spent on just the very first step of simply documenting the workflow. Unfortunately, existing agentic workflow benchmarks in machine learning almost exclusively focus on automation only and ignore these other 3 stages of BPM. WONDERBREAD fills this gap in the literature by providing the first benchmark designed specifically for evaluating multimodal models on the full suite of BPM tasks. So, besides a cute logo, what exactly is WONDERBREAD? WONDERBREAD is a dataset and benchmark containing 2,928 human demonstrations of 598 distinct workflows, so about 5 demonstrations per workflow. We define 6 novel tasks covering documentation, knowledge transfer, and process improvement. Finally, we provide automated evaluation harnesses for each task, which leverages a combination of LLM as a judge and programmatic validation. Each demonstration in WONDERBREAD contains a lot of data. First, we provide the raw screen recording of the demonstration itself. Second, we provide keyframes taken from this video. These are static images that are synced to each action taken, for example, clicks, keystrokes, and scrolls. Third, we provide a trace of timestamp metadata associated with each action, so a click might have an XY coordinate, or a typing action will have a string associated with it. Finally, we also include a standard operating procedure, or SOP, which is simply an English description of all the steps that the annotator took in the demonstration. As you'll see in the next few slides, having these SOPs is essential for being able to evaluate models on BPM tasks and is a unique contribution of WONDERBREAD in addition to the high quality and depth of our demonstrations. So now that we've covered the data, let's get into the actual tasks and results. I'll only have time to discuss one of the 2 tasks per BPM stage that is included in the benchmark, but you can see the paper for more details. Our first task group evaluates a model's ability to document a workflow, and I'll focus here on the SOP generation task, in which the model is given a video recording and it's tasked with writing down all of the steps taken in that video. We measure 2 metrics. The first is precision on the x-axis here, which is how many steps in the model-generated SOP were actually in the video demonstration. And we also measure recall on the y-axis, which is how many steps in the video appear in the model-generated SOP. Each point is a different model and prompting strategy, and here in the top right, we find that GPT-4 achieves the best performance with a zero-shot score in precision of 0.8 and recall of 0.88. The second major task group that we evaluate is knowledge transfer. The task here that I'll focus on is visual question answering, which requires the model to answer a complex reasoning question about a demonstration. We curate 120 total such questions. Some examples are in the bottom right of the slide, and the results are plotted in the radial plot in the top right. As you can see, the human annotator is in green, and each of the models are different colors. We find that while models can generate syntactically coherent answers, so scoring highly on clarity on the left and compactness at the bottom, models tend to omit important details as shown in their lower scores for soundness at the top and completeness at the right. The final group of tasks revolves around process improvement. Here I'll highlight the SOP ranking task, in which the model is given a set of 4 to 5 SOPs and must rank them by perceived quality. Surprisingly, we find that the rankings generated by models have almost 0 correlation with the rankings of human raters. This gap indicates an opportunity for future work in better aligning model perception of workflow quality with that of humans. In addition to improving human model alignment of workflow understanding, there are many opportunities to build upon WONDERBREAD. These include adding more diverse real-world enterprise workflows to the benchmark, as well as using our existing dataset of roughly 3,000 high-quality human demonstrations to fine-tune AI agents for automation and BPM tasks. If you're interested in using our dataset or evaluating your models, please check out our website at wonderbread.stanford.edu, where you can find links to the dataset, evaluation code, and paper. Finally, I'd like to thank all of my co-authors, collaborators, and advisors for their support on this project. Thank you.